Welcome, esteemed viewers, to an intricate exploration of Robert Boyle's work, a journey into a mind whose contributions echo powerfully through the annals of modern science. Today, we delve into the technical depths of Boyle's pioneering experiments and theories, merging quantitative analysis with historical insight. Boyle's legacy as a natural philosopher, chemist, physicist, and theologian is not merely anecdotal. It is built on rigorous experimentation, innovative apparatus design, and profound theoretical insights. We will guide you through his early influences, the evolution of his experimental methodology, and the transformative impact of his seminal work, The Skeptical Chymist. We will examine his contributions to the formulation of Boyle's law, a fundamental principle in physics that quantifies the inverse relationship between pressure and volume in gases. Moreover, we will explore Boyle's integration of scientific inquiry with theological reflection, an interplay that remains a source of inspiration and debate among scholars. Along the way, we scrutinize his inventive mind, his novel approaches to chemical analysis, and the detailed numerical data from his experiments. Expect a deep dive into the specific apparatus he refined, including the evolution of the air pump and its implications for precision measurement. Prepare for a script replete with technical details and fact-driven analysis that brings out a unique, that creative interpretation of Boyle's work, a synthesis that is as enlightening as it is rigorous. Robert Boyle's origins are as illustrious as his later scientific achievements. Born on January 25, 1627, at the imposing Lismore Castle in County Waterford, Ireland, he was the seventh son and the 14th child of the first Earl of Cork, whose considerable wealth and influence provided a fertile environment for intellectual pursuits. From an early age, Boyle received an education that was as diverse as it was refined. His initial instruction in Latin, Greek, and French, delivered by private tutors, laid an essential foundation in classical studies, an influence that would later permeate his approach to both science and theology. A formative period began at Eton College, where, under the watchful eye of eminent educators such as Sir Henry Wotton, Boyle's aptitude for critical thought was further nurtured. His time at Eton, although rigorous, was marked by peculiar diversions from learning the native Irish language, a choice reflecting the prevailing cultural dynamics of his environment. His subsequent travels across Europe, particularly his winter in Florence in 1641, further expanded his intellectual horizon. Immersing himself in the advanced astronomical debates of the day, particularly through the prism of Galileo's revolutionary ideas, Boyle was exposed to a cosmopolitan blend of empirical observation and philosophical reflection. This blend of classical education and first-hand scientific inquiry would become the hallmark of his career, demonstrating that his formative years were as much about absorbing technical facts as they were about experiencing diverse cultural and intellectual milieus. Robert Boyle's scientific investigations stand as a testament to the marriage of empirical rigor with innovative experimentation. Drawing inspiration from the philosophies of Francis Bacon, Boyle was among the first to reject abstract theorizing in favor of meticulously designed experiments. He established his laboratory at Stalbridge House in Dorset, where he methodically recorded observations, measurements, and anomalies with almost obsessive precision. Boyle's practice was marked by an unwavering commitment to the principles of quantification, a commitment visible in his numerous experiments involving air and its properties. This was not mere tinkering. His work was laden with careful numerical analysis. In one notable experiment, Boyle measured gas volumes under varying pressures and temperatures, thereby empirically validating the relationship now celebrated as Boyle's law. His apparatus, an improved version of Otto von Guericke's air pump, was engineered to minimize human error and maximize reproducibility. Collaborating with contemporaries like Robert Hooke, Boyle's involvement in the Invisible College catalyzed a culture of shared ideas and methodological cross-pollination. Their collective efforts led to significant refinements in experimental design, particularly in the measurement of pressure differentials and the quantification of chemical reactions. The level of technical detail in Boyle's work is exemplified by the meticulous calibration of instruments and his rigorous statistical approach to data representation. Boyle's contributions to chemistry are encapsulated in his groundbreaking 1661 work, The Skeptical Chymist, a text that reshaped the very foundations of chemical science. Deeply embedded in its pages is a rich tapestry of experimental data and rigorous argumentation that challenged the alchemical paradigms of his day. Boyle approached chemical substances not as mystical elements subject to transformation by arcane forces, but as systems governed by measurable properties and predictable behavior. He employed quantitative analysis to differentiate between mixtures and compounds, thereby laying the groundwork for the modern understanding of elemental composition. Within this treatise, Boyle systematically critiqued the classical notions of salt, sulfur, and mercury as the sole principles of matter. Instead, he postulated that substances were composed of undefinable particles whose interactions could best be understood through precise experimentation and analysis. The text is not only a manifesto for chemical empiricism, but also a compendium of experimental procedures, each with detailed measurements and documented observations. Boyle's analysis utilized a variety of instruments, including balances and early thermometric devices, to provide numerical support to his hypotheses. He stressed the importance of reproducibility and consistent measurement, arguing that chemistry should be held to the same standards of rigor as mathematics and physics. In 1663, Robert Boyle's scientific pursuits were given further momentum with the inception of the Royal Society of London for Improving Natural Knowledge. Boyle's active involvement in this newly established organization not only broadened his collaborative horizons, but also embedded his work within a community dedicated to advancing rigorous scientific inquiry. His experimental achievements, particularly his formulation of Boyle's law, became cornerstone contributions that resonated throughout the society. Boyle's collaborative projects with influential contemporaries, including Robert Hooke, allowed for continuous refinement of experimental techniques. Among these initiatives, Boyle's precise experiments on the compressibility of air underscore a methodical attention to numerical precision and statistical accuracy. His work went beyond mere theory. It provided a demonstrable, quantifiable relationship between pressure and volume, using a refined pneumatic engine that greatly reduced the labor intensity of previous designs. Boyle's integration within the Royal Society also provided him an influential platform to challenge contemporary philosophical paradigms. His role in council discussions and his critical exchange with other natural philosophers enriched his approaches to both chemical analysis and physical measurement. The Society's records detail rigorous debates, clarifications of methods, and the collaborative spirit that define these gatherings, elements that continue to inform current practices in experimental research. While Robert Boyle was a trailblazer in empirical science, his dedication to theology was equally profound. A devout Anglican, Boyle perceived the study of nature as a pathway to understand the divine intricacies of creation. His theological writings are imbued with rigorous logical reasoning and a determination to cross-examine standard dogma with observable natural phenomena. In works such as Disquisition about the Final Causes of Natural Things, Boyle utilized empirical evidence to argue that the elaborate design inherent in natural processes was evidence of divine orchestration. His analyses were not abstract musings, but were meticulously supported by numerical data and experimental observation. For instance, Boyle's arguments on the physical possibility of bodily resurrection hinged on replicable chemical reactions and transformations, ideas that he likened to the reduction of compounds to their pristine state in a controlled environment. This intersection between science and faith was further exemplified by his involvement in translations of the Bible, notably financing the printing of both the Old and New Testaments in the Irish language. Boyle's writings reveal a curious engagement with the physical diversity of mankind, proposing theories that linked complexion and physical attributes to what he described as seminal impressions. He advanced a monogynist hypothesis, arguing that Adam and Eve, presumed to be originally white, were the progenitors of all human races. His approach was interlaced with data-driven observations, which, for his era, were remarkably systematic. Boyle recorded instances of varied appearances and correlated them with reproductive outcomes, suggesting that the observable differences in skin color and other features were the result of subtle variances in the semen. In addition, his commentary on physical beauty extended beyond mere color, placing heavy emphasis on the symmetry and proportionality of the human form. His assertions were met with a mix of admiration and skepticism by his contemporaries, some of whom found his detailed, almost forensic analysis of racial differences to be as innovative as it was contentious. Robert Boyle's personal story is intertwined with his broader scientific legacy, characterized by both remarkable intellectual vigor and poignant human connections. His lifelong dedication was frequently balanced by close personal relationships, none more significant than his intellectual partnership with his sister, Catherine Jones, Lady Ranelagh. Their mutual exchange of ideas and experimental findings provided not only emotional support, but also critical peer review of his work. Despite bouts of failing health in his later years, Boyle continued to contribute tirelessly to the scientific community, leaving behind a trove of meticulous experimental records and theoretical treatises. His establishment of the Boyle Lectures, funded in his will, has endured as a testament to his commitment to defending Christianity against skeptical inquiries. The legacy of Boyle's quantitative methods and his insistence on objective measurement can be observed in today's rigorous laboratory protocols and statistical approaches in natural sciences. In conclusion, Robert Boyle's work continues to inspire and challenge the most astute minds in science and philosophy. His pioneering experiments, careful attention to numerical detail, and integration of methodical empiricism with theological reflection have made him a timeless figure in the annals of modern inquiry. Through deep technical analysis, we appreciate how his meticulous studies on gas compression, chemical analysis, and experimental reproducibility laid the foundations for disciplines that dominate today's scientific landscape. Boyle's legacy, encapsulated in seminal works like The Skeptical Chymist and in his influential role within the Royal Society, reminds us that the pursuit of knowledge thrives on precision, innovation, and an unwavering commitment to evidence. As we reflect on his multidisciplinary contributions, we are compelled to recognize that true scientific progress is achieved not only through groundbreaking discoveries, but also through an insightful integration of empirical data with broader philosophical and ethical considerations.